Summer Physics 3-4. So this is the last week of this course, and we're going to introduce a new subject, and it's the subject of waves. So how can energy be transferred between two places? There are two ways energy can be transported from one place to another. First, energy can be put into an object with mass, and the object will then move between 2 points and then transfers its energy when it arrives at its destination. So when you throw a ball, the ball carries energy and then transfers it to wherever it lands. Well, that's not a very good way to transfer energy, because that would mean the only way we could get energy from one place to another is by throwing things around or having meteorites strike the earth, or that's the only way energy could be transferred is by some object like that. That's not a good way to do it. So fortunately, nature provided a better way. So waves are the main way nature transports energy from one place to another. Waves can move energy from one place to another without being carried by an object with mass. Now I'm going to qualify that statement here in a little bit. But waves are pure energy. So waves have no mass or weight, but they might use objects with mass to be transported from one place to another. So I'll explain what that means when we say it doesn't need an object with mass. So there are two kinds of waves we will talk about in this class. First is transverse waves. Transverse waves move up and down as they travel through space. So think of a roller coaster. So they actually literally go in this up and down, or it could be side to side. They could be oriented in different ways, but it's basically up and down fashion like this. The other type is longitudinal waves. These move back and forth as they travel through space. So think of a spring. It squeezes. That's called compression. Then it expands. Okay, so you have the transverse up and down roller coaster waves and the longitudinal, which are the back and forth type of waves. What is a medium? A medium is a substance with mass through which a wave moves. Transverse waves, such as light waves, can move without a medium. That's why they can travel through the vacuum of space from the sun to the earth. So all the energy we receive from the sun is in the form of a type of transverse wave called an electromagnetic wave. Light waves move faster through a vacuum than they do through a medium such as air. Longitudinal waves, such as sound waves, can only move through a medium. Consequently, there is no sound in outer space. Sound waves move faster through a more dense, thick medium, such as water, than through a less dense medium, such as air. In other words, sound moves about 4 times faster through water than it does through air. So let's distinguish between what the first slide said, which is you're transferring energy by putting it into an object like a ball, and then you're throwing that ball to somebody, and then when that ball gets to them, it releases the energy. How is that different from a medium, which is something with mass? Well, the medium, what it does is it carries the energy a little distance, and then it transfers it to another part of the medium, which wiggles and transfers it to another part. In other words, when you hear the sound of a person's voice, what is happening is the air molecules in their throat are wiggling. They're wiggling the next air molecule, and they're wiggling the next air molecule, and they're wiggling the next one and the next one and the next one until it gets to your ear. So that's different than if the air molecules in their throat were coming out of their mouth and going all the way to your ear. It's not the same air molecule. It's just one air molecule wiggles the next, wiggles the next, wiggles the next, and so on. That's what a medium does. So that's different than throwing a ball from me to you, is different than what a medium does. A medium is a substance that a wave travels through, such as air or water. Electromagnetic, such as light waves, do not need a medium, but they can travel through a medium. So clearly, a medium air would be a medium, and light can travel through air, but it does not need the air to travel through it. It can travel through outer space where there's no air. Longitudinal waves do need a medium because they're back and forth waves. They have to squeeze the next piece of the medium and the next piece and the next piece, like air molecules wiggling one to the next one to the next one to the next one. So the birthday girl is floating in outer space where there's no air, and she's out there with a police car. She can see the lights because light waves do not need a medium. She cannot hear its siren because sound waves do need a medium. So even if that siren is blaring and she's right next to the car, she won't be able to hear it because there's no air out there or water or anything else to carry the sound to her ears. But she can see the light because electromagnetic waves such as light do not require a medium. What are sound waves? Sound waves produce a longitudinal wave that causes the air molecules to move back and forth. This is the same pattern as a spring. So we'll call this guy Longo. Longo makes longitudinal waves by squeezing his accordion. Now, any instrument will make longitudinal sound waves, but the accordion is a good example because you know how it plays. The man squeezes it back and forth, back and forth, back and forth. And that's the way sound waves move through space. Again, they squeeze the air molecules and then release. And then the next air molecule, set of air molecules gets squeezed and then released, squeezed and released. So it's a longitudinal or back and forth type of wave. So a spring moving back and forth also makes a longitudinal wave. Okay, so the top one, those are air molecules, so you can see how they're being squeezed together at one point and released, squeezed together and released. And down below you see how the spring does the same thing. It squeezes together at one point and then it's released. And that takes care of this lesson on basic waves.